Welcome to this deep dive into optional in Java 8. Today we will explore the ins and outs of how optional helps you write cleaner, more robust code by addressing one of the most notorious issue in Java, null values and the dreaded null pointer exception. Friends, whether you are a seasoned Java developer or just starting out with Java 8, this exploration will give you insights into how optional fits into modern Java programming. In Java, dealing with null values has always been cumbersome. It has led to countless bugs, most of which boil down to the dreaded null pointer exception. Java 8 introduced the optional class to mitigate this by offering a more elegant way to handle possible null values. This is essentially a container object that may or may not contain a value. Think of it as a box that either has a gift in it or is empty, but you are never left in doubt about its state. First of all, let's understand why was optional introduced. Before Java 8, null checks were part of nearly every Java project. It was not uncommon to see code like checking a null object before writing any code, just like if object not equals to null, then we further start write our main business logic. The problem is it's verbose, error prone and often leads to overlooked edge cases. Optional was introduced to remove these boilerplate checks and reduce the risk of null pointer exceptions, bringing Java closer to functional programming paradigms. This shift is more than just a convenience, it transforms the way we design our APIs and handle data safely. Let's understand how we can create optional instances. There are three ways to create optional instances depending on the data you are handling. Optional dot empty method. Use this method when you want to explicitly represent an empty optional, kind of like an empty box. Optional dot off method. This method perfect when you are certain that the value is non-null. It throws an exception if you try to pass a null value. Optional dot off nullable. This method is more flexible as it accepts both null and non-null values, wrapping null into an empty optional. Follow this given code example how you can create them. Notice how clean the code is without the need for clumsy null checks. Once you have an optional, how do you check if it contains a value? See, there is two commonly used methods, is present and if present. Is present method checks if a value exists inside the optional. If it does, it returns true. If present method, this is a more functional approach. It allows you to pass a lambda function to operate on the value if it exists. Check this given example using if present method is much more aligned with modern functional programming practices. It allows you to eliminate the need for explicit if statement. Here is where optional really shine. Instead of invoking methods on a potential null object, you can leverage the or else method. It returns the value inside the optional if present or provides a fallback value if not. This is particularly useful in scenarios where you want to ensure that your code never returns null, providing a default behavior when the optional is empty. Let's get into some advanced functionality. Or else method. This method always evaluates the fallback values regardless of whether the optional contains a value. While simple, it may not be the best for performance in all cases. Or else get method. Here is where lazy evaluation comes into play. This method only evaluates the fallback value if needed, making it more efficient. Or else throw. Use this method when you want to throw an exception if there is no value present in the optional. Check this code example for your better understanding. These distinctions between or else method and or else get method can be subtle yet crucial optimization in performance critical code. Now let's look on the integration of optional and stream API. Optional integrates beautifully with Java Stream API. It provides a functional way to manage possibly empty results from stream operations such as find first and find any. This ensures that your stream operations don't break down into null pointer exception chaos. When dealing with large data set or pipelines, optionals seamless interaction with stream is invaluable. Optional shines even brighter when used with functional programming concepts in Java 8. For instance, the map function allows you to transform the content value if present without checking for null. Please take a look of this self-explanatory below code example for your better understanding. Combining optional using filter. Filtering optionals lets you enforce conditions on the value inside, providing a clean way to handle optional logic without null checks. For instance, the filter method allow you to apply a predicate to the optional values. This makes it easier to handle conditional logic with avoiding the clutter of traditional if else structure. Avoiding optional misuse. Optional is not a silver bullet and it can be easily misused. For instance, using optional in method parameters or fields is generally discouraged. Also, if you are tempted to use each present method excessively, you might be missing out on more functional approaches. Remember, optional is meant for return types and handling values functionally. Real world use cases of optional. Optionals are ideal in situations where you want to clearly signal that a return value might be absent. For example, method in your service or repository layer might return an optional when a request record is not found. This way you avoid ambiguous return values like null. Optional versus null checks. Here is side by side comparison of how optional is improves readability and safety in your code. Let's compare these below code snippets before Java 8 and with Java 8 optionals. The optional based approach is not only more concise but also free from null handling complexities. Potential pitfalls. Although optional is great, but overusing it, especially in performance sensitive code, can have drawbacks. For instance, boxing up primitive values like int inside optional create overhead. So be mindful of its uses in hot code paths where performance is critical. So now let's conclude our session here. So optional is a powerful feature that helps you write cleaner, safer and more readable code by avoiding nulls. It's not just a syntactic sugar, it enforces better API design and makes your code more robust. So start using optional in your Java projects, especially in return types, and take your functional programming skill to the next level. That wraps up our deep dive into optional in Java 8. Hopefully you have gained a solid understanding of how to harness the power of optional in your daily Java development. Thank you for watching and make sure to apply this concept in your code. I will see you in the next video. Till the time, check my others Java 8 videos along with this video. Thank you so much.